What is friction? Friction is the opposing force that acts on bodies that are in motion or are about to start moving. This opposing motion arises due to the irregularities present on the surface of objects. No surface is perfectly smooth, every surface has some amount of irregularities present in them. When these irregularities mesh with the irregularities of another object, we can say that friction is occurring and an opposite force is being acted on the object. The friction acts on both the objects participating in the sliding. What is angular momentum? Angular momentum measures the tendency of an object to rotate. It depends on three main factors: mass, velocity, and the radius of rotation. When we multiply these three quantities, we get the value of angular momentum. Angular momentum arises due to rotation of an object, and rotation arises due to torque applied on the object. A torque is a couple force acting on the object which gives rise to rotating effect. Due to inertia, the object keeps rotating unless the irregularities make it slower and finally bring the object to rest. Does friction affect angular momentum? Yes. We have already discussed in the above sections that friction opposes the motion of an object, hence a rotating object comes down to rest when friction acts on it. This way the rotational speed becomes less, and so the angular momentum also decreases. Friction is responsible for slowing down the rotational speed of the object. Now, if the surface was smooth, there would be no resistance to the motion and the speed would not have been compromised, and so the angular momentum. How does friction affect angular momentum? There is no direct formula that derives the relationship between friction and angular momentum. Friction reduces the rotational speed of the object. Reduction in angular speed directly affects the value of angular momentum. The irregularities on the surfaces mesh with the irregularities of other object. This was the angular speed is opposed by friction and hence gets reduced. As a result of this, angular momentum also reduces. Does friction increase angular momentum? Friction can never increase angular momentum. The reason being that friction always opposes any kind of motion. Here the rotational motion is being opposed. When a motion is opposed, the velocity of the object is directly affected. The velocity of the object is reduced as the friction starts acting on the object. As the velocity is reduced, the angular momentum is also reduced. Hence answering the question. Friction and angular momentum relationship. The friction and angular momentum share no direct relationship between them. Meaning there is not a single formula that can show the relationship between these two. Although we can find the numbers using following few steps. In simple words, the friction reduces the amount of angular velocity with which the object is rotating. The angular velocity affects the angular momentum directly, so as the angular velocity keeps decreasing, the amount of angular momentum also keeps decreasing. Applications of friction. Although we see friction as a negative term, but there are many places where friction is desirable. Let us see the examples at which friction is desirable. The applications of friction are given in the list below. Walking. While walking on frictionless floor, we want to be able to move forward, as our legs will simply keep slipping. This is because there are no irregularities meshing between the legs and the ground. On a road with friction, the irregularities on our feet and the surface will mesh and produce a forward reaction force which help us in walking. Running. Running is an important application of friction, just like walking. Just like walking, while running also, our legs will keep sliding when the floor is frictionless. A floor with friction will simply provide a forward reaction force which will propel us in the forward direction. Brakes. Without friction, we would not be able to apply brakes on the car. This is so because the irregularities are required to mesh with each other, only then the opposing action can be achieved. This is why the roads are made with irregularities and the tires are also given design such that they assist in proper braking. Cycling? Cycling is also an example of application of friction. The friction is used to propel the cycle in forward direction. The forward reaction force drives the cycle to move forward. Pen grip? We have observed grips on pens. The grips are used to provide enough friction that our fingers do not slip while writing. Without friction, it gets difficult for us to write as our fingers will become slippery and the pen will slip out of our fingers while writing. Holding an object? Holding an object requires friction. The irregularities mesh with each other, this way an upward force acts on the object that is being held. Thus creates a lifting action. Driving a car? Driving a car is similar to cycling. The wheels of the car rotate on the road. The road has irregularities on it which mesh with the irregularities on the tires. This way a forward reaction force is given to the tires and propels the car in forward direction. Gear meshing? Gears have teeth which act as big irregularities on a gear wheels. These gear teeth mesh with each other in order to transfer the motion from one end to another. Gears are used for multiple purposes. Mainly for transmission of force and motion and also stepping up and down of speed. Belt drive in a belt drive, a belt is kept on a wheel that rotates with certain angular velocity. The kinetic energy of wheel is then transferred to the belt and then finally the belt transfers the kinetic energy to another wheel on which the belt is kept. This transfer of energy takes place only due to friction acting between the wheel and the belt. Please visit our website lambdageeks.com for more articles on technology, engineering, mathematics, and various other domains. Scientific calculator and many more other tools.